Amit, do you see there are 9 squares here?
Yes, sir.
So, you know how Sudoku works?
Yes, I know.
Right? This is very similar to Sudoku, but you don't have to know Sudoku also. I'm just trying to see if I can motivate it through something that you know already. Here are 9 squares, 1, 2, 3, 4, 5, 6, 7, 8, 9. Can you plug in the 9 numbers 1, 2, 3, 4, 5, 6, 7, 8 and 9 here so that each side adds up to the same number and each row and column, everything, whichever way you add should add up to the same number.
Okay.
You were saying that you want some programming challenge, right?
Yeah.
I thought I instead give you something like this. Go ahead, try.
So I have to choose the numbers from this set.
That's right. No repetitions, no repetitions allowed. Yes.
The sum should be equal to one particular number.
Correct.
All the rows, all the columns.
Correct. So this, you would be surprised to know that this is more than 2000 years old.
Really?
It was first noted in China, and there's very interesting history you can look up on the internet. But the best part is 3 cross 3 is very interesting. As you increase the dimension, it gets more interesting. I'll tell you something a lot more interesting once you solve this. Go ahead.
Sure.
Firstly, do you think this is easy to solve?
I think it's very easy.
Very easy. Go ahead.
Okay, let me use this number.
Yes, 2, 6. Correct. So which would be 6, 7, 8, 15. Adds up to 15. So if you write some numbers here, even that should add up to 15. Go ahead.
What I have left? 6 I use, 7 I use, 2 I use.
Maybe, yeah. So what, write something. 9, then 11, which means should be a 4. So what happens here? 2 plus 9 is 11, plus 4 is 15. 2 plus 6 is 8, 8 plus 7 is 15. Perfect, but then you should put some numbers here so that this adds to 15, this adds to 15, not just that. This adds to 15, this adds to 15. Oh, I forgot to tell you, even the diagonal should add to 15. Go ahead.
Okay, this is great. Use 9, I use 4, 6, 5, 11. Oh.
Okay, do one thing, you go ahead and try. I'll take a break and come back.
Sure, sir.
Once you're done, let me know.
Okay.
Alright? Yeah, perfect. Hey Amit, you have done it. I've been watching you. Yes, perfect, perfect, perfect. Yes, so it's a 4 plus 3 plus 8, which is 15. Perfect. You can write 15 properly here. And then 15 here. 9 plus 5 plus 1 is 15. 9 plus 6 is 15. Let me remove this. And yeah, 15 here. 15 here. You see 8 plus 1 plus 6. 15. 7 plus 5 plus 3, 15. Oh, boy has done it. Okay, 4 plus 9 plus 2, 15. 15. Yes. Look at this. 9 plus 6 is 15. 8 plus 2 plus 5 plus 8 is 15. Perfect. I'll ask you another question now. This is just one way of doing it. There could be many ways to do this, or I don't know. This may be the only way. Can you tell me if there are many ways of doing this?
There can be multiple solutions also.
Yeah, why not?
Oh my god, it took me a lot of time to get this solution.
So give me a chalk. So what you can possibly do is you can try writing a piece of code as and always,
Yeah,
right?
that's
And
my
try to see what are the total possible ways. How will you go about this?
See, I solved this in a brute force way.
Trial and error, you mean?
Trial and error.
Correct.
I put some numbers, check
Okay.
what the sum is going on.
Right.
And with iteration, I found this.
Correct.
So for this, I can write a code definitely.
Mm-hmm.
And the computer can do it in fraction of seconds.
Mm-hmm.
So I will write a code, same brute force way.
Perfect.
But it will give me solutions.
All the solutions? Try doing it.
Definitely.
I will tell you something more. Two things. One is one dimension lower. By that I mean, let me look at a 2x2 board, which would be something like this. So can you tell me what would be the version of this problem here for 2x2? There were 9 squares here. So you considered 1, 2, 3, 4, 5, 6, 7, 8, 9. For 4 squares, what would you do?
1, 2, 3, 4 I will consider.
Can you quickly try if this is possible with 1, 2, 3, 4? I'm going to give you just 2 minutes time. Go ahead. Something that you will observe for 1, 2, 3, 4.
Okay.
Basically, 1 should be there somewhere, for sure. Okay, diagonal should be same as this. One, 3, maybe.
Yeah, exactly.
Do one thing, let me write it in bold. So you say 1 here and a 3 here, sum should be 4.
Exactly.
This should also be 4, but you will have 2 and 4 left, this becomes 6. You see, you can try all possibilities, you will observe that it's impossible to do it in 2x2. Well, it is not possible to do it in 2x2, it is possible in 3x3, and surprisingly for 4x4, it's so difficult that your computer is not enough. Ordinary desktop is not enough for you to find a solution for 4x4. Guess why? Think about it, write a piece of code, and maybe you try explaining why it is not possible for 4x4.
Sure.
Yeah, good job.